Hi, I'm Lars. Welcome back to the C# workshop. This video is going to finish up conditionals for the if and else, and it's going to talk completely about the switch. If you haven't seen the first video, you may want to go back and watch it. So if you're ready to continue on, let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. We're going to kick off this video, Conditionals Part II, with a little bit of a revisit back to the original Booleans that we were working with. At this point, I think it's a good time, I think everyone should be comfortable with conditionals, to talk about the negation conditional. It looks like this, so I'm just going to put this out here. We talked about this before, where we would have, bool, and we would set bool equal to, say, false, and then we would say b is equal to negated or not b. So this here would set b equal to false, and then this here sets b equal to true, because it's saying assign it not b. So whatever b is, we don't want it. There's a little bit of a difference with this, the way this works, and if we do something like, I'm just going to say age is equal to 10, and we're going to bring back the teenager, and that's going to be 13 less than age less than or equal to 19. So that is a Boolean value now, and since we are using 10, then we want to see if the teenager, if you have a teenager, let's go with if teenager is equal to false. Sometimes we want to look for the negative, sometimes we want to look for the positive. So if teenager is equal to false, and I'm just going to pull this in here, then we're going to write you are not a teenager. Otherwise, we're going to say you are a teenager. So if teenager is not, if this is equal to false, then we're going to come in like this. All right, so let's start here with a breakpoint, and we'll fire this up. So b is equal to false, and then this one here, like I said, b is equal to false, and when you put this in, this not b, this negated b, and I'm going to put that in the watch for you, it's equal to true. So right now b is equal to false, but when we run this code, we're going to assign it what is the opposite of b, and this is true. Now this does confuse people, all right? Not that this confuses them, but this next part here confuses people. We're going to set age is equal to 10, and then we're going to set the teenager. So age is teenager is equal to false. And so you're going to test this. You're going to say if teenager is equal to false, you're going to say you are not a teenager. And that's what came out down here. All right? You are not a teenager, which is what we would have expected. What people get confused on is this is also a comparison, all right? It's a test. It's not an assignment. You're not taking the value of teenager right now. You're saying, is teenager the Boolean false? Okay, because it's going to accept it that if it's teenager, it's going to be true. If you put this in front of it, it's going to be false. This is equivalent of this line below it. You may ask, why do people do this? And it's very common. It's been around in the C language forever. So let's run this. And I'm going to skip past the B's. And there's your teenager is equal to false. This says teenager is equal to false. And if you look at not teenager, it's going to say true. But I'm going to tell you right now, this will step in to you are not a teenager. All right, it's the exact same value as this. Teenager equals false. This should say false. And that's how this works. So down here it says you are not a teenager. If you were to put this and say if teenager, then you're going to have to switch these around. And we'll restart. So teenager is false. If teenager means if teenager is equal to true. Well, teenager, when it just has teenager there, it's saying if teenager is equal to true. And it's not, because it's equal to false.
So you're still going to get "you are not a teenager." And that's exactly what you got. You're not a teenager. So that's just something I really want to let sit in your head, because I'm going to start using this in future videos. And I will explain it again when we get to there. Now, something that you can come across is you could have some number, I don't care what you call it, just a num, and we're just going to set that number to 5, all right? And you may have some code that looks like this, which is pretty ugly, but we're just going to go down this whole path here. So sometimes you have to look at assigning stuff or just printing stuff out. And I'm just going to use the months. So like num1 is equal to January, and then we're going to put an else in here if num2 is equal to February. And we're just going to go on down with this, all right? And I've got this already laid out here. I'm just going to paste in the rest of these months because I don't want to take up like this entire video of just typing. So this here is if the num is equal to 1, it's going to be January, num equals 2, February. We have 5, so we're expecting May to come out. So let's just get this thing run and see what comes out at the bottom here. And we have May. At the bottom, yes, there is an else statement. I always put else statements in for my conditionals because if something goes wrong, I want to know what. I just don't want to know, well, we didn't hit here. And we might even put in here invalid month and add in the number so that we know that what somebody put in. So like if I come in here and I put in 55 and we run this, you're going to say invalid month 55. Now you've got data that you can go back and you can debug why is this a problem, all right? So this is just the precursor to what we're going to get started in. This looks kind of mundane. It's hard to read. I've seen people do this, and what they do is they're like, oh, let's get rid of all these things here. And we'll put this up at the top like that. And yeah, it looks good, but it's mundane. It's really hard to read.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
The second thing that we have, you can do this for the months, and then a lot of times you end up with something like this that will say you want to find out what quarter you're in. So you'll drop this in. Doing things like this is very common in companies. Like you might need to find out, hey, if the month is this, I need a quarter. I might need to print December because we get dates and stuff that are 2025 01 18. So let's run this with May number 5. And what you'll see down here is May and Q2, which is what we should have found because you came down, so you got your number is equal to 5. It's going to write out May, then you're going to go to the next set of if statements where these are ORed in. So is it one of these? Is num equal to 5? Yeah, it's quarter 2. Now, this is really hard to read. It's a lot of screen to come down. And yeah, I have seen people take these things and they've done this. All the way up. All right. And yeah, this is like, oh yeah, we're removing code, we're removing code, we're removing code. And after you get some experience, you start thinking about this. Why would somebody do this? Well, it's because they don't know any better. If they did, they would switch this over to a switch statement, which is a little cleaner, and it's mainly made for this. The way a switch statement works is you come down through the start, and you look at different cases. Only the case that is true will actually execute the operation for it. Everything goes all the way down to the bottom to the end when they're done. So otherwise, you can't go from case 1, fall into case 2, fall into case 3. All right. Once case 1 is done, it breaks out and exits the switch statement. There is a default that if none of the cases are met, default will run. This is like the else statement for an if-else statements. All right. They are very important, and I recommend to always have them. All right, so let's take a look at some switch statements. So there is something called a switch statement that you throw a number into, and then you have cases. So this would be case 1, number 1, so number equal to 1. And here you would say right line January, and then you put a break in. And this is the right way to go about doing something like this if you wanted to do this. Okay? And you take it all the way down. And when you're done, it would look like this. And I'm going to just kind of zoom out a little bit, but it would end up looking like this, which is a little easier to read. And how you would convert these guys is switch statements have the ability to stack cases. So if you wanted to stack cases over here, you could do this. And we can get rid of that. And then this will say if it's case 1 or case 2 or case 3 that you do quarter 1, quarter 2, quarter 3, quarter 4. And that works out really well. Another unique feature that switch statements have, switch statements are kind of made for this, is you can have a conditional hit in the case and then do an operation, and then you could say go to case 3. Just like it looks like here in case 1, you do the operation, you say go to case 3, and it will drop down and execute case 3 until it hits the breakpoint, and then it will end out. And like in case 2 on the drawing, you could say I hit case 2, going to do that operation, then you could say go to default, and it would jump down to the default and finish that operation. So let's take a look at one of those. For this example, we're going to use a specification. We have a total of 0. A is a character that can come into this piece of code. And if A comes in, you're going to add 1 to total. Then you're going to add or subtract whatever D is currently doing. Likewise with B, if B comes in, you're going to add 2, and then you're going to add or whatever C is currently doing. If C comes in, you're just going to add 3 for right now. If D comes in, you're going to add 4. And if none of these come in, you're just going to add 10. So we start out with a char. I'm going to call that a character. And right now, we're just going to set that to A. And we're going to have, this is an integers total, and we're going to set that equal to 0. So the switch statement starts out just like this, just like any other one. And you're going to switch on a character. And the case of A, you're going to say total is equal to total plus 1. And yeah, you're going to throw a break in there. And you're going to do this for all of these, B, C, and D. All right. And you're going to do the default. So instead of the default saying case, it does say default, spelled properly. And that adds 10 to it. Get rid of that. This is going to be D, C, and B, 2, 3, and 4. And this is pretty simple stuff. And let's just do a simple debug here. And we're going to right line out total, put a space, and just put the total in there. And let's see what this comes up with. So right now we have total equal to 1. So we have part of this working. Okay, so we put an A in, we added the 1. Now we need to change the code to add or do whatever D is currently doing. Okay, I'm going to say this do whatever D is currently doing, and this is going to be do whatever C is currently doing. So as soon as we get this total, we need to put something here called a goto, and you can say case D, semicolon. Now, the break is not needed anymore because you're not coming back, and that's the part that usually messes everybody up. You can't come back. So we're going to do that for A, and then for B, we're also going to do it, but we're going to go to C. Or sorry, yeah, going to go to C. So if we put a breakpoint here and step into this, let me zoom in on that some. So we start stepping down, and it's A, we know it's A. The total is going to get added to 1, and then your goto case is going to drop this down to case D. Then we're going to add an additional 5 to it, and then we're going to get out. Now, your total is going to say 5 down here. Now, these are a little different, okay? These could be dangerous. And something we haven't talked about yet is what's called an endless loop. Okay? Because we haven't talked about loops yet, but this is going to be the first kind of instance of it. So let's run this again. If we have case A, adding 1 to it, we're going to case D, and these are why these are dangerous. These are why people do not like using them anywhere in your code. Because the case statement here, you're going to add 4 to it, and then you're going to go back up to A, and it's going to cause this endless loop. So it's going to just keep on going up, down, up, down, up, down, up, down, until you run out of memory. And if you have a lot of memory, this could take a long time. So we're going to step through this. See, there's your total, got added. And it's just going to keep on going. All right. So let's step down into this. I'm going to get rid of all these break statements. And we're going to add total to the break, to the watch. So you're going to go from here to D, and back up to A, back down to D, A, D, A, D, A, D, A, D, A, D, A, D. And it will just go forever. All right, total will have to get to at least 2,147,000 before it'll blow up. That's my guess. Let's just hit F5 and see where it goes. I'm going to drop a breakpoint in there. That's how many numbers we've already gone through. That's how fast this will run. Now, if you needed to do this for some reason, okay, you could put in here if total, like if you needed this operation to do this until total was a certain value, so you could say if total is greater than 50, break. And this is what people don't do. All right, so if it's greater than or equal to 50, we're going to break. Now we're going to run this again. I'm going to put a breakpoint here. Just let it run. So we went 80, 80, 80, 80 until we actually hit 50. And now when we break, it will jump out. So that will get us out. Just like this break here does, it gets us out of the switch name. This will get us out too. So these are possible, but these are rare cases. So don't just start going to work. And the main point of me showing you guys how to use gotos in a switch statement or gotos in general, without that knowledge, you will not be able to understand what a looping structure is and how they actually work. So again, use gotos on caution. If you're going to use a goto, make sure you have some sort of failsafe on it. So you can make a switch look a lot like the if-else statements for a variety of things. And there's something new that has been added to switch statements. And I don't know how many people really know about these things, but they're called case guards. So when we were talking about the age of 14, remember we had, a teenager was 13 and 19, and adults 21. This would be something that most developers would look at and go, there's no way, it's not going to happen in a switch statement. Actually, it can. So I could come in here and say, I need a case, and I'm going to redefine this int when, and I'm going to grab the actual Boolean right out of this and do this. And I'm going to put in there that this person is a teenager. And that'll work. And likewise, if I want to do the adult thing, it's where it's greater than or equal to 21. And you can do the last one here where, when your age is this. So you're going to have to put double parentheses around that one. Get rid of the semicolon, put a colon in here. And that will say you are classified, unclassified. And that should work just fine. So let me go up here and comment all this out. Actually, we'll just get rid of it for right now. Before we start this off, let's add a default in, because if we always want to have a default in a switch, you always want to have an else statement at the end of an else if or an if. So next thing we need to do is we need to switch around that sign because it was wrong, and then we hit console app. So we're going to step into here. Look at that. You're a teenager, and you come out and you're going to get you're a teenager down here, right here. All right, so let's make this here 10. So you're not a teenager. Rerun it. And step in. That gets tested. It's not greater than 21. So we're going to jump right into here, and you're going to get you are unclassified. And that's what we got down here in our output. You are unclassified. So now let's change this again to 20. Step through here. You still got you are unclassified. If I put in here 25 and then you run this, step in, it's greater than 21, but it is outside of this realm, and it works. So that one came out. Here's the weird one. Say you're -1. See? Unknown. That's why you never know. I mean, everyone never thought that was ever going to hit, but someone could have put a negative number in.
Thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed this video, and I hope these videos helped you understand how conditionals work. In the next video, I'll be taking a deep dive into looping. You're going to find out that they're a lot like conditionals. You're always welcome at the C# Workshop, and as always, have a nice day.